Now, I've spent for the most part, the last 10 or so years, I've been an independent hands-on software architect, which means, I don't really know what that means. It means that I don't really work on just one project. I don't work for one employer. I go where people need me. And that's been wonderful. It's given me the opportunity to work on a number of different projects across a whole host of domains. And it's given me a great deal of exposure to tools. Now, most of these projects that I get called upon to work on, some of them are planning projects. Some of them say, we want a little bit of outside expertise to help us make sure we're on the right track architecturally. But most of these are rescue projects. These are things where everything seemed like it was going well in the beginning, and then somehow it all went off the rails. There were challenges, and then they call on somebody like me to help them make sense of where they are, bring order out of the chaos. So a lot of what I've done have been rescue projects. And disproportionately, those troubled projects have centered around microservices. So what I want to do is I want to share 6 secrets that I've learned. And I want to try to set some general context. I'm going to share some ideas. Some of these will be familiar if you've come to my other talks because there's overlap in terms of how I approach software architecture. And I want to create each session in a way that they stand alone, that you don't have to have gone to the entire Carducci track to have the full picture. So there may be a few slides that are familiar, but otherwise I'm just trying to add necessary context for the hour that we're here together today. Now, I'm going to be speaking a little bit at a higher level. I'm not going deep into circuit breaker patterns or anything else. I want to take a little bit of a step back, talk about microservices, some of the challenges, some of the aspects that we should consider, and give you some food for thought. Now, the most important thing that I've discovered in my career, 15 years now in largely software architecture roles, is this. Nobody really wants microservices. We think we do. A lot of people talk about it. A lot of people are excited about it. I mean, microservices for many years have almost been the free in conference bingo, that somebody is always talking about microservices. But they don't actually want microservices. So what do they want? Well, they want organizational agility. They want a reasonable release frequency. They want a release confidence. They want testability. They want room for growth. We hope we're going to be successful. We hope we're going to grow. We want to be able to scale. They want enforced modularity. Breaking everything apart seems like that's going to help in that regard. They want efficient use of compute resources, elasticity, and they want an architecture that they won't be ashamed of. They want something that maybe they can be proud of. Look what we accomplished. And I think one of the sources for this is a useful tool that is sometimes misused. And that tool is these star rating scorecards that were produced by Mark Richards, who's here this week, a wonderful guy, good friend of mine, and Neil Ford, another good friend of mine. In their book, Fundamentals of Software Architecture, they have a second edition out. It's one of my favorite books on software architecture that isn't that one. But in fact, it's the most highly recommended book that I've been recommending for years. It was required reading in my last kind of real job where I was chief architect at a Fortune 100 financial company. But when we look at these star ratings, you're at the layered monolith, 1 star, 1 star, 1 star. Ooh, 5 stars, 1, 1, 1, 1, 1, 1, 1, 1, 1, 3, 1, 5, 2, 1. Not a very good scorecard. That's a lot of 1-star reviews. Then we look at microservices, 5, 5, 5, 5, 5, 5, 5, 5. The most 5-star ratings. So you can see the root of the emphasis on microservices. Now, in fact, Martin Fowler, the luminary, the legend that is Martin Fowler, in 2014 wrote on his blog, "We've seen so many projects use this style, microservices in this context, the last few years, and the result so far has been positive, so much so that for many of our colleagues, this is becoming the default style for building enterprise applications." That's a ringing endorsement. But I have a problem with the star rating system. What does 5 stars even mean? Now, a while back, I was looking through my food delivery app. In my case, it's DoorDash. I know we have like Zomato and some other ones here. Uber Eats used to be here. I don't think it's around anymore. Is that right? Yes, it's not around, or yes, it is? It's not around. There's a great story, by the way, a cautionary tale with Uber Eats, where they made some poor API decisions, or one of their partners, one of their suppliers did, and they ended up giving away free food for 3 or 4 days because of misunderstanding about ideas around REST and response codes and things like that. But DoorDash is the one that I use in the U.S., and if I open up DoorDash from my condo in Parker, Colorado, there's a very highly rated restaurant. It is a fine dining establishment, Eddie Merlot's, seafood, things like that. 4.5 stars. That's pretty good. 4.5 stars, right? Do we agree? Now, there is another restaurant that is in my delivery radius that maybe not quite as high as 4.5 stars for this high, very expensive, fine dining establishment. It's a little lower, 4.2. Now, for a very fancy, very hoity-toity, kind of pinkies out type of establishment, 4.5 is pretty good. If there was another restaurant that was 4.2 stars, would you expect reasonably that that would be a comparable dining experience? Yeah, of course. Here is the 4.2 star restaurant. McDonald's. Not exactly a paragon of fine dining. And it points to the challenges that we have with star ratings in general, because are all 1-star ratings created equally? No. We don't have a standardized scale. In fact, I'm not proud to admit this, but I have ordered from McDonald's and had it delivered. Get my chicken nuggets. Sometimes a man needs some chicken nuggets. And at the end, it pops up for a review, and you know what I said? 5 stars. I got exactly what I was expecting. And that's kind of what that means. It's very subjective. And in fact, Randall Munroe, the creator of XKCD, created this star rating chart here, pointing out that this is how reviews really work, at least in most countries. 5-star means it's only got 1 review. 4.5, excellent. 4, okay, everything else is garbage. Now, my wife has a hobby. And what she does is whenever we find a place, a restaurant or some kind of experience or something like that, that was just truly transcendent, what she'll do is she'll go online afterwards and she'll read all the 1-star reviews. All the people who came to this magical place and hated it. It's very entertaining. And one of the things that was interesting was, for some places, the source of their 1-star review were exactly the things that she loved the most about that place. So one person's 5 stars, somebody else's 1 star. Now we're getting into architecture. It all depends. It's all subjective. It's all contextual. Then we went to Japan. 2 years ago, we went to Japan, and we found this amazing sushi restaurant. Phenomenal. And now, it wasn't, if you were here for Ken Sipes' talk earlier today, he talked about that film, Hero Dreams of Sushi, that legendary sushi chef, the best sushi chef in the world. That's 5 stars. Wasn't quite there, but from where we were, you could see that level of greatness. And it had 3.2 stars as a rating. Because in Japan, they approach star ratings differently. There's a great Reddit post that in Japan, they say people are much more harsh to rating. And somebody explains it. It's a culture here. 3 stars, they have a standardized scale for everything. 3 stars means as expected. 4 was pretty good. 5 is legendary. And they even said this. He says, somebody talked about this 2 out of 5, which is horribly negative review in most kind of, at least Western contexts. I had a fantastic meal and the price is really cheap. I'm happy to have found this place while out for a walk. However, there was a plastic bottle rolling in the car park. I wonder if the boss knows. 2 stars. But let's look at this. Let's measure this. Let's actually see what we're talking about. Now, a very famous organization that is making heavy use of microservices, that is Amazon.com. Now, let's pick a few of these. We have agility and deployability. These are valuable things. What does this mean? What does 5 stars mean? 136,000 deployments a day at Amazon. Now, we might think we want 5-star deployability, we want 5-star agility. How many people here are doing 1 deployment a day? No hands. Me neither. I'm not doing 1 deployment a day. But we want 5 stars because 5 stars is good. What about elasticity and scalability? What does this mean? What does 5 stars mean here? 50,000 HTTP requests a second. That's a lot. Anybody deal with that kind of scale? But 5 stars is good. Microservices are good. You know what? It's bad. Monoliths are bad. That's what everybody tells me. I've been hearing that my entire career. Microservices is good. Monoliths bad. Well, let's go in the same sector, e-commerce, and let's look at Shopify. Shopify famously has a Rails monolith. How many times have you ever heard in your life Rails doesn't scale? Right? That's one of those memes that move around. But they have a modular monolith for agility and deployability. 2 stars, that's pretty bad. Like, we're doing better with our 1 deployment a week, right? No, they're doing 40 deployments a day. How do you feel about 5-star versus 2-star now? That's still more than any of us in this room, myself included, are doing. How about elasticity and scalability? 1 star. 1 star means terrible, right? 1.3 million requests a second. How many people are dealing with that level of scale? Once again, no hands. But nobody wants a 2-star architecture. And this is why in my book, I tried to take a different way of doing qualitative measurements. Because I don't talk about 5 stars or 1 stars, because 5-star means good and 1 star means bad in our minds. I talk about extremely high scalability, extremely low simplicity. Talk about these extremes. It's a different way of framing it, and that makes more sense. Extreme has a very different connotation than 5 stars. It becomes a different discussion. Now, what's funny was a year after that blog post by Martin Fowler, he had a follow-up. And he says, as I hear stories about teams using microservices architecture, I've noticed a common pattern. 1, almost all the successful microservice stories have started with a monolith that got too big and was broken up. 2, almost all the cases where I've heard of a system that was built as a microservice system from scratch has ended up in serious trouble. This pattern has led many of my colleagues to argue that you shouldn't start a new project with microservices, even if you're sure your application will be big enough to make it worthwhile at some point. That is very different from a year ago. That's what experience teaches you. And in fact, Gartner, unironically embodying the Gartner hype cycle, for years they've been trumpeting microservices, and they did the same thing. They did another U-turn. And in 2017, they predicted by the end of 2019, 90% of organizations that try to adopt microservices will fail. They'll find the paradigm too disruptive. So what I learned, and I've told this story before, so I'll tell you the very short version, was I found myself in the middle of nowhere, in a ghost town, a town where everybody had left, and a guy said, there's nobody here, and you will sell me a lot of land very cheap. I think I'll buy it. And not only did he buy it, he set up a pottery studio in the middle of nowhere, hundreds of miles from any other humans on a road that probably got 10 cars a day. I met the man, the mad potter, Byron Seeley, in Jeffrey City, Wyoming. And I was driving through and I saw his studio. I had to go in. Curiosity got the better of me. And as he's giving me a tour of his studio and his retail space and everything else, I couldn't help but ask, this is a weird location to set up your business. And I said, Byron, do you get a lot of business? And he looked at me and said, what's a lot? I was not prepared for the follow-up question. And so I was on the spot. I said, I don't know. And he said, neither do I. I know what enough is, and I get enough. It was a really insightful thing, and that stuck with me. We don't want a lot. We want enough. When we engineer or architect for a lot, we over-engineer, we bring in massive complexity. So, yeah, this is wisdom from the Mad Potter himself. Now, all of that said, these things still matter. But is the microservices architecture really the only way to achieve these things? And the answer is no. When you start thinking more holistically about software architecture, the answer is no. So the first secret is nobody really wants microservices. They want something that they think microservices are going to give them. And as thoughtful and effective architects, it's our job to figure out what those things are, figure out what enough is, and help the organizations and the teams achieve that. Now, the second thing I've learned, and one of the reasons this field is so hard, is there's no single definition of microservices. We have this regrettable tendency in our field to overload terms. We have microservices over something we're calling microservices over here. We have something we're calling microservices over there. We have something that we're calling microservices over there. I'm sorry, I suddenly forgot how to speak. And but there are only very small superficial similarities to these different implementations. And we start to associate, we start to define this very specific term by the broad overlap between all these different implementations. Well, if I have multiple services, it's microservices, or teeny tiny services, it's microservices. And as a result, we go and hire people and we put on the job description, we're looking for somebody who has experiences with microservices. Oh, I have experience with microservices, but it could be anything. Any kind of distributed system we end up calling microservices. And now as an architect, maybe you design a microservices architecture, you're trying to communicate this to the teams, but they have their all weird historical baggage, all these different things we're calling microservices, and this is a real problem. Because as architects, we want to try to get the technology teams and the business all moving in the same direction to accomplish common goals. But what happens in practice is all the different teams with all these different definitions that are not compatible in many cases, everybody's moving in different directions. And the thing is, when you take all of this stuff apart, you have to put Humpty Dumpty back together again. And that's not going to work well if we're not operating with a lot of precision and a shared context. And this is what I call the flat taxonomy problem. That in architecture, we kind of look at things, we have monoliths and we have distributed systems. And these are the bad ones, these are the good ones. And it's like, well, event-driven, that's just microservices with queues or PubSub, right? Or monoliths, right? These are the bad ones, those are the good ones. It's the lowest common denominator. We start associating the capabilities of the architecture with the topology of the architecture. But that's not where the capabilities come from. And Martin Fowler said this in 2014. While there's no precise definition of this architectural style, which means, by the way, it's not an architectural style because an architectural style, going all the way back to 1992, is something that does have a very precise definition. We're not just saying like, oh, it's microservices-ish, so I'm going to call it a style. An architectural style means something very specific. But it's another term that got lost, just like Agile or DevOps or anything else in our industry. There are certain common characteristics around organization, around business capability, automated deployment, intelligence in the endpoints, and decentralized control of languages and data. So even Martin Fowler says, I'll know it when I see it. But the reality is breaking an application into hundreds of tiny pieces doesn't magically make all those illities appear. In the same way, a layered monolith doesn't presage a big ball of mud. It's a product of decisions, architecturally significant decisions. And the thing is, there's no single set of decisions. And a lot of architecture books out there can be very prescriptive because sometimes people struggle and struggle and struggle, and finally the stars align and they design an architecture that works really well in their specific domain, with their specific organization, with their specific user base, and their specific everything. And they say, aha, I've cracked it. And they write a book and they say, this is exactly how you should be building microservices. Except that's what they needed, not what you need. And so we can't be over prescriptive about this. And the other thing is, maybe as an architect, you're going to do your due diligence. You're going to read Mark Richards. You're going to read Sam Newman. You're going to dive into the minutia and really understand that microservices is a whole family of architectural styles with different decisions and different trade-offs and different inflection points. And then you're going to try to communicate this to the team. But the thing is, the architect who does all this work, they're not the ones doing the implementation. You're not building this, at least not primarily. And so we talk about things like patterns. Patterns are supposed to be a high bandwidth mechanism for communicating ideas. But that only works if we have shared definitions of the patterns. But with such a wide range of variations, that means at any meaningful scale, there is no shared definitions of any architectural pattern. So that gets us into the flat taxonomy problem. It gets us into the space where we're just sort of lumping a bunch of styles together based on superficial similarities and topology, and we end up with this kind of reductive thinking. Well, your layered monolith is a monolith, and a monolith is basically a big ball of mud. Big ball of mud is bad, monoliths are bad, therefore it's all the same. But big ball of mud has a definition. Big ball of mud is, according to the person who popularized the term, Joseph Yoder and Brian Foote, a big ball of mud is a haphazardly structured, sprawling, sloppy, duct tape and baling wire spaghetti code jungle. We've all seen them. The code shows unmistakable signs of unregulated growth and repeated expedient repair. Information is shared promiscuously among distant components of the system, often to the point that nearly all the important information becomes global or duplicated. The overall structure of the system may have never been well defined, or if it was, it is eroded beyond recognition. Right? We know this. Programmers with any shred of architectural sensibility shun them. Only the ones that are unconcerned about architecture and perhaps comfortable with the inertia of the day-to-day chore of maintaining these things, patching holes and failing dikes, are content to work on such systems. But there's some key words in here: haphazardly structured, spaghetti code jungle, right? All of this stuff. And this means this is clear that these can't be the same thing, because this is not that. This is definitely not that. We can't define architecture by its lowest common denominator. Mark Richards defines a microservice as a single-purpose, independently deployable unit of code that does one thing well. That's a great answer. It's true, but it can lead us in the wrong direction. And we want to do the pattern right, but only if the pattern is right. So we want to be careful of pattern-driven architecture. Patterns aren't architecture. They are a side effect of architecture. That's what comes out after you do the architecting work. And you say, hey, this is good. This is useful. And then somebody else does it and they say, this has actually been useful for us too. And once we see that this certain set of architecturally significant decisions has broader value, we codify it, we call it something, and then it goes out into the world and it decays and everything else. And this is why I've long believed we are overdue for a more comprehensive architectural model. So my challenge to you is to stop thinking about patterns and start thinking about decisions. You see, every project that we work on is the product of a set of decisions. Now, within that set of decisions, there exists a subset that are architecturally significant. They directly impact the capabilities, the abilities of the system, and their measure. And so when we look at all these various patterns, as diverse as they are in terms of topology and implementation and their abilities, they are all the result of a handful of architecturally significant decisions. And those architecturally significant decisions don't necessarily stay in the realm of one of these patterns. What makes the modular monolith unique is it borrows and learns from many of the architecturally significant decisions that made microservices successful, the modularity, the independence, the decoupling. But they said, you know what, maybe we don't need 1,000 of these things because we don't need certain aspects of those abilities, but we like the modularity. We like the testability. We like the release confidence. We like a lot of those things. So we're going to take some of those, but put them in a monolith. The only thing we're going to do a little differently is we're going to say, you know what, instead of fine-grained components, we want a monolithic component. Other than that, we're borrowing a lot of the same things. Now, these decisions, these architecturally significant decisions, they revolve around component granularity or topology or how module boundaries are defined or how interfaces are constrained or constraints around code reuse, if and how asynchronous communication will take place. But behind all of these patterns and all their variations is ultimately a set of architecturally significant decisions. These are some, there's a lot more. But the capabilities, the abilities, they don't come from the patterns, they come from the decisions. Nothing magical happens when you break an application up into a bunch of pieces. It's actually all about how we constrain the degrees of freedom. If we go back to our big ball of mud for a moment, the big ball of mud is defined by no constraints, no rules. It's a free-for-all. You want a 30,000 line God class? Have 5. You want to make everything global? Go for it. There are no rules. We are children left unattended. Have at it. But when you start to constrain the degrees of freedom, no. We're not going to have a 30,000 line God class. We're going to constrain the degrees of freedom. We're going to constrain a class such that it has a single responsibility. We are going to constrain that we have interface segregation. We are going to constrain that you must use dependency inversion. A lot of times we think of these as best practices, but these are constraints. And that's what induces maintainability, modifiability, testability, and a whole bunch of other abilities in your code. And the same is true of your architecture. It's all about the constraints. And this was the light bulb moment for me in my journey as an architect. Does anybody here know who Roy Fielding is? Okay. Yes. Yeah. He was one of the architects of the web. He created REST. And if you've read, he published his, in 2000, he wrote his doctoral dissertation, Architectural Styles and the Design of Network-Based Architectures. Now, the odds are, has anybody read it? The odds are if you have, you skip directly to chapter 5, because chapter 5 is when he first starts talking about REST. And then if you're like me the first time I read it, you get mad because it doesn't tell you anything about APIs, because it turns out REST has nothing to do with APIs. It's an architecture. And that was that. But I read it. I didn't understand it. I got mad. And then I read it again. I didn't understand it, and I got mad. And then I thought, maybe insanity is doing the same thing over and over again and expecting a different result. So I read the whole thing. I'm going to be honest. I didn't understand it. And then I read it again. And then I realized this was brilliant. And it wasn't about REST. It was about giving us a better way to design and communicate network-based architectures. This is what it's about, architectural styles and the design of network-based software architectures. REST was just an example of how to use the tools that he gave us. And instead of saying, thank you, Dr. Fielding, we argued with him on the internet for 10 years. I actually reached out to him to ask him if he would write the foreword to my book. He didn't respond. And I don't blame him, honestly. He's probably just done with this because it was such a turbulent thing. But he didn't come up with this idea. In fact, he cited a very influential book, one of the earliest books on software architecture, not the earliest, but one of the first probably half a dozen books, and that was Foundations for the Study of Software Architecture by Perry and Wolf. And they did a lot of the work on architectural styles. They understood that constraints were a great idea from system theory that applied to architecture. But if you go further back to the 1970s, you see the same ideas being touched on in Fred Brooks' The Mythical Man Month. We see it again touched on in Software Architecture Perspective on Emerging Discipline. It was the centerpiece of Fielding's dissertation. There was another great paper by Tibermacine et al. Called Software Architecture Constraint Reuse by Composition, and the tailor-made software architecture model, which is a big part of the book itself, was in there. The idea is not new. Connecting the constraints to the capabilities have been shown again and again to work in theory and in practice. But the big thing that I was able to contribute to stand on the shoulders of these giants was taking lessons from the brilliant work that Mark Richards and Neil Ford did, where they started score architectures, because even back in 92, they said, you know what? The way these constraints work in architecture is very consistent, and it appears to be deterministic. And that means, in theory, we could weight the pros and cons, the trade-offs of every single atomic architecturally significant decision, these constraints. And so you get design time feedback. You can get deterministic outcomes. How many times in your career have you or somebody around you or a project you've worked on have this beautiful idea in theory about the architecture, and then you put it in the real world and it doesn't come anywhere close to that? Because it's a guess. It's a crapshoot. It's a gamble. But it doesn't have to be. And that was the really incredible thing that I discovered, that we can get design time feedback on our architecture and get deterministic outcomes on the other side. So I touched briefly on one of my little pet rants about architectural styles. We don't mean something that is similar-ish. A lot of times we think of style, and this makes sense. This is intuitively, this makes sense. That we have a style and we'd say, oh, well, that's a Neo-Georgian style, or that's a 60s style. And we're talking about a vague set of values and aesthetics. But in architecture, an architectural style is specifically a named coordinated set of architectural constraints. So when we were applying these 6 constraints in the case of REST, that is the REST architectural style. And this is why Roy Fielding and all the Restafarians in the world would be very quick to point out when you called something REST, oh, this is a REST API, and the Restafarians would say, actually, no, it's not. You're violating 2 of the constraints. We're talking about we're using HTTP and JSON, yeah, but you're not using Helios, you're not doing this, you're not doing that, you're violating the uniform interface constraint. But that's the point. And that was what Fielding argued. He's like, please stop calling it REST. It doesn't have to be REST. The whole point of REST was this was our problem we needed to solve with the web, and we solved it. You can have something different, but don't confuse everybody by calling it REST as well when it's a different set of constraints. So let's define patterns by core constraints. There's almost as many variations of those 9 patterns as there are implementations. But if we look at them by their core constraints, we take something like microservices, and at the core, one thing that is common in most microservice, like most honest microservice implementations, there's a lot of people who are calling they have like 3 monoliths that span like 25 bounded contexts each, but there's 3 of them, so they're microservices. I see a lot of that. But if we're getting closer to the truth, and people who have really rigidly studied this, there are a set of common constraints: fine component granularity, single purpose, does one thing well, independently deployable, that's exactly what Richard said, domain partitioning, this is really key, because you can't can't find these boundaries without finding the natural seams in the system in the business. Highly decoupled components. This is extreme decoupling. Isolated databases. Typically, one microservice owns one database. We don't have that shared database. We get rid of database coupling. And now everything else we do is on top of that. This is why I call this an abstract style. This is not a blueprint. This is not a recipe. It's like a base class that you inherit, you extend, and you override. That's how you get your architectural style. But these are kind of the key ones. You start taking these things away. You take away independent deployability. I don't care how many microservices you have. You have a distributed monolith. If you have to deploy them all at the same time in a specific order, in lockstep, you have a distributed monolith. You have the worst of both worlds. So back to the second secret. There's no single definition of microservices, but this model, this tailor-made software architecture model gives us a common foundation to avoid overlooking key constraints. Now, the third secret that I've learned in all of these rescue projects is that the trade-offs of microservices are often much more extreme than you think. Like, let's go back to this statement again. 90% of organizations, I can almost guarantee you, that it's not that 90% of organizations got the constraints wrong, but they don't realize that some of these constraints have dependencies. You can't just say, oh yeah, we're going to constrain to do domain partitioning. You can't, because that means you need to know what your domains are. And not only that, you have to have an organization that is structured in a way that is aligned to those domains. This is Conway's Law, right? Conway's Law taught us in the 1960s that organizations that produce systems are condemned to produce systems that are copies of the organization's communication structures. And over time, it turns out that applies to software too. In other words, it doesn't matter what your architecture looks like in Lucidchart or your C4 diagrams, you're going to ship the org chart. And so you can't just, as an architect, say, thou shalt be domain partitioned. The organization needs to be designed in a way that that's actually going to work. You need to know what your domain boundaries are. So it means you have to do the work of DDD, and your teams have to be aligned that way as well. Otherwise, everything gets coupled back together and you have a distributed monolith. Independent deployability. That's not just everybody has their own release pipelines. How often have you worked in a distributed system and you're working on something and you're about to ship your code, but you're testing, you have a shared dev environment where everybody's kind of doing continuous integration build with their service and your service and somebody else's service, and you're doing all that integration stuff in dev, and then you go to do a release, and it turns out what that other team has in dev is not what they have in production. And then you're like, oh, crap. There goes my organizational agility because now I'm waiting for that team to finish. And then we have to make sure that we deploy both of these at the same time. Or how about independent release cycles? I can't develop a microservice if I have to wait for you to let your API emerge. This is how most of us go do API design. It's like, oh, you need this stuff? Okay, I'll write the code and I'll wire up my controllers and I'll come up with and we'll see what it ends up looking like. And then every time they change their implementation because they don't have good abstractions, they break the API again. Nobody's designing their APIs. Very few people are designing their APIs, and they're certainly not designing the APIs before they write a line of code. This is a really important thing to remember, especially in distributed environments. Your API design is more important than your code. You can throw away the code, but that shouldn't break your API contract. We want very good abstraction in our API. This is one of the things that REST gives us, or when you do it right, when you actually do REST, it's one of the things that it gives us. So there's a whole lot of these different things, high degree of automation. There's a ton of these things that we need. In fact, I've got a giant list of these from another slide from another deck, right? This is a very tall order. Now, Neil Ford is often very fond of saying when he talks about microservices, he says, you have to be this tall to ride the microservices ride. And what it means is you have to have all of these other things in place in your teams, in your environments, in your organizations, that to enable those constraints. You can't just prescribe those constraints and expect this to happen. This is what the organization needs to look like. This is how the teams need to operate. I had a conversation. I was talking with a client one day. I was on a call. It was one of these all hands calls, and the vice president of technology was on there. He was issuing one of these dictates from on high, and he says, our goal for the next year is to make everything microservices in this organization. Now, I'm old enough and I'm jaded enough and cynical enough that I thought, let's see what happens. I come off mute and I say, that is an amazingly terrible idea. That didn't go down very well. And then afterwards, I kind of reached out to a handful of people and I said, look, I understand. I get it. I said, but the thing is, you're trying to emulate successful IT organizations. But successful IT organizations, their success is not a consequence of using microservices. Microservices are a consequence of their success. And adopting microservices isn't going to make your organization successful any more than buying a Formula One race car is going to make you a race car driver. You have to be a race car driver to drive a Formula One car. And not only that, it doesn't matter. You could have the best driver in the world and the most advanced Formula One race car in the world. But if you don't have a pit crew operating with laser precision, all you're going to get is an expensive, unbroken string of spectacular losses. Have you ever seen a modern-day pit crew operate? Today, a car can come in from the moment that race car comes to a stop. The crew is going to leap into action, change all 4 tires, completely refuel the fuel tank, wash the wiper, the windscreen, all of this in less than 2 seconds. That's the level you have to be playing at in Formula One. If it takes 5 minutes to do this, guess what? You lost. You lost spectacularly because everybody else who's doing this well, they're doing that entire pit stop in less than 2 seconds, 1.8 seconds. And that's the level that we have to be playing at to do microservices. But anyway, so this is why a holistic model doesn't just say, oh, here are the constraints, but we have organizational, team, and environment constraints that are dependent on those constraints. And this is why this is why the book has the subtitle, A Comprehensive New Model and Approach, because we can't think about architecture in a vacuum. So the third secret, the trade-offs of microservices are often more than we expect. And this is why the model that I'm sharing with you, and it's also open source. You don't have to buy the book. I'm not trying to sell the book. By the way, just nobody gets rich writing a tech book. We just spend hours and hours and hours, but it's not. We don't do it to get rich. We do it to share things that we've learned with other folks. But connecting those things, that's a really important thing. Now, yesterday I was in this room, and I had a conversation. I asked for a show of hands, who was in the middle of a monolith to microservices migration, and somebody raised his hand. And I every time I ask this question, this is my follow-up question: what year are you in? And he said 3. And usually when this question, it's 3 to 5 years is where they're at currently. And I'd say, how much more time do you think it's going to be? I don't know. A lot more. But so we often over-engineer with microservices because we've been scarred by the difficulty and the pain of these decompositions. But it's not necessarily hard. You see, what I learned with magic and this model is fundamentally when you change the way you look at things, the things that you look at change. And that was a profound realization for me. So when I stopped thinking about architecture as topologies, as patterns, and I started thinking about architecture as the composition of these different architectural constraints, because that's what they are. They're atomic building blocks that we can arrange one way and we get one thing, we arrange them a different way, we get a different thing. Just like everything in engineering, everything is composites. This is a composite. My laptop is a bunch of composites. Everything in our modern world is just composites, different combinations of the same 109 or so basic elements. And that's what the constraints are. And that means that evolution of architectures can be as simple as adding or changing constraints. The key thing is some constraints are harder to change than others. And I'd love to do a deeper dive into that aspect of things, but I actually have an entire talk on that tomorrow. That's what the Agile Architecture talk is. And I hope you're available for that, but if not, it will be recorded. It will be available on developersummit.com. But the key thing is, in fact, the way the book is written is I start with a big ball of mud and I evolve it to a layered monolith, into a distributed end tier. I take that layered monolith and evolve it into a modular monolith, start decomposing that into a service-based architecture, into microservices. So I take one system and change a couple constraints at a time. I take that one system through not just the 9 patterns, but dozens of intermediary styles as well. So it's a super useful thing in there. But the main thing is going from the layered monolith to a distributed end tier architecture. It's very straightforward because we're breaking the system apart at the seams. But going from a layered architecture, you'll be decomposing across existing boundaries is straightforward. But going from a layered architecture to microservices is not. And the reason is we don't have natural seams in our code. Like if you have a modular monolith, it is trivial to take one of those modules out and put into a standalone microservice. It's not even a one sprint activity. For a team, you could do everything in one sprint, certainly, and have plenty of time to spare because you're decomposing at the seams. You're just extracting a single module. But with the layered monolith, you have to cut new vertical slices, and that is enormously hard. Changing module partitioning is hard. Decomposing a system along the existing modular boundaries is easy. And so because of this, I've come up with a new taxonomy to think about these things based on how difficult the system is how difficult the constraint is to change. So at one of the highest levels, I have technical partitioning, like we have the controller layer and the services layer and the business logic layer and the repository layer, and right, we know this design. Horizontal layers, that's technical partitioning. We're partitioning by technical boundaries. That's a natural thing that we do. Versus domain partitioning, where we take those vertical slices that are defined by those domain boundaries. That is this going from, let me find my little laser pointer guy here. Going from here, where's my laser pointer? Going from here to here, that's what takes years. Going from here to here to here, those decompositions are very straightforward. And so that's why you can get an idea of how hard this migration is going to be, just as a general estimate, as a general guide, based on how far away the abstract styles are in this taxonomy. That's the hard part. So decomposing a monolith is not necessarily difficult, but decomposing across module boundaries is. Now, the fifth thing that I learned, and this is where teams struggle a lot, is we get overly hung up on this idea about granularity. Granularity needs to be absolute. Everything has to be fine-grained. Everything has to be within a single bounded context, one thing very well. And a lot of times we design systems that are too fine-grained, and we're not considering all the various aspects and component and conditions around this and context around this. But fine-grained is a guide. It's not a demand. What I like to do is try to let metrics drive decisions. I try to let broader context drive decisions. If I have two microservices that basically can't do their function without talking back and forth all the time, that's a good sign they probably need to be together. We want loose coupling, but high cohesion. And cohesion means that things that belong together are together. Like not everything has to be nanoservices or picoservices or anything else. And we should be measuring our architecture. For a couple of years, and actually we got in a nice conversation after Ken Sipes' session in this room earlier today. He talked about databases. And I was sitting right there, in fact, and his hypothetical question was, we have a highly normalized database, and we've proven our concept. We want to scale, and we expect it's going to be growing 100x in reads. So what should we do as architects? And I kind of challenged him a little bit on that. I said, well, what makes you think you can't scale a relational database? Now, I say that, and I had lots to say on the subject. Afterwards, we walked back to the main building, and we continued that conversation. And I said, look, I was a DBA for a while. No, don't hold that against me. DBAs I know are not popular. Believe me. In fact, you know what DBA stands for, right? It stands for don't bother asking. But what I learned is, sure, we design the databases and the indexing and we tune things and the rest of it, but it's not like we do that work and then we're done. We just sit around drinking coffee all day. Or I'm really getting into the chai again. But I wonder if I can bring some home. Everything is better here, food-wise, tea-wise, and everything. I'm so envious of y'all. But we spent a lot of time monitoring. And architecture is the same. It's as much about monitoring as design. Oversight is not something that we do after the fact. It's a near constant activity. So how do we measure architecture? In general, I've got a whole chapter on metrics, which is probably the most boring chapter in the book. We have SLAs and SLOs and various things like that. But we're trying to find that definition of enough. And so when we're looking at metrics, we need to ask the question, what is the business value of each metric? What is the business value of each constraint? But we want to make good data-driven decisions about that, this microservice should be this big, that one can be that big, this one can be in the middle, right? There's no one size fits all. We want deliberate data-driven decisions, not dogmatic decisions. That's where you need to be as an architect, thinking and thoughtful. So granularity need not be absolute, and multi-grain services are a good solution. This, honestly, if you have multiple microservices, dozens of microservices, hundreds of microservices, if they are all uniform in granularity, that's probably dogmatic. Not guaranteed, but it's a good sign. It's probably dogmatic. This is the kind of thing that I want to see. And this is a mistake a lot of enterprise architects make. They're like, well, everything is going to be this certain way because it is decreed from the ivory tower. And the last one that I have for you is that monolith first is often practical. This is not a bad place to be. Again, as long as you are starting with evolution in mind. I'm going to go deep into this in the Agile Architecture session tomorrow. And if you can make it, great. I'd love to see you again. If you can't, no hard feelings. It will be on developersummit.com. Now, one of the challenges with this is I've seen a lot of organizations gravitate towards microservices because they think it's giving them enforced modularity. They're like, well, no, everything's this whole separate service, so that will keep everything modular, right? Right? It's going to keep everything modular, right? And then everything gets kind of chaotic, and then we end up going to a monorepo, and then all of a sudden, every microservice is importing libraries from every other microservices, and you've got another distributed big ball of mud. We're worried about architectural decay, but microservices aren't an inoculation against that. But the same is true of modular monolith, right? Where we have these, if you're not familiar with the modular monolith kind of abstract style, essentially you have individual standalone packages or assemblies that are all kind of bundled together and compiled together, but inside of these packages, everything is typically internal, and that's supposed to be a bit of enforced modularity because you can't peek into my code, although you can. Obviously, we do it. If you've ever written unit tests, which is going to be in a separate package, against your internal classes, you can do it. You can use reflection, like the compiler will let you if you try hard enough. Also, it's not very hard for somebody to go in there and say, you know what, I just want to get this story shipped because we got a Friday afternoon release that we're not going to talk about. And so I'm it's almost going home time. I got 2.5 minutes left in this talk. I'm just going to go in here and make it public. What's the worst that can happen? But it's a slippery slope. And so this is where architectural governance comes in. ArcUnit, .NET Arch Test, or ArcUnit Net. These are automated testing frameworks that allow you to put these tests in place that when people violate the constraints, it will break the build. And that's part of that monitoring. It's part of that governance. And we've seen that putting everything in separate services is not a guarantee of decoupling. And putting them together is not a guarantee that it's going to dissolve into a big ball of mud. So, but governance is part of our job. So the last one, monolith first, is often practical, provided adequate architectural enforcement and governance is in place. So to recap the last 90 seconds that we have, nobody actually wants microservices. They want something that they think microservices is going to give them. It's our job to figure out what that is and deliver the right set of trade-offs. Over-engineering is a poor substitute for design and requirements analysis and deliberate thought. There's no single definition of microservices. Don't let the flat taxonomy fool you into overlooking key aspects or let it put you into a corner. Use more sophisticated architectural thinking tools to design an architecture that fits and that can evolve. And also, because of this, you can't just prescribe architects to microservices. You have to be more precise in your communication. The third one, the trade-offs are often more than we expect. Just like one person's 5-star is another person's 1-star, we want to adopt a holistic approach that surfaces both technical and non-technical risk of every architecturally significant decision. And you will probably also need tools to lead and drive meaningful organization-wide change. Decomposing a monolith is not necessarily difficult. Don't be fooled into thinking you can't grow into microservices over time. Understanding the atomic architectural primitives, these constraints that underlie these patterns and how they can be combined in different ways is key. Granularity need not be absolute. Taking a more holistic and data-driven and pragmatic approach helps balance cost, complexity, and scale. And the last one, monolith first, is often practical. And that's where we're using sophisticated approaches to design architectures that fit now but can evolve as your needs do. And with that, I know we're out of time. So I will say thank you so much for being here. Thank you for making it to the end of the day. And please connect with me on LinkedIn. I would love to keep this conversation going. Thank you so much.